All right, so for our first problem with the compound inequalities, what I'm going to do is I'm going to show you how to do this both ways. So we can look at this as being the shorthand way of writing an AND statement. So this could be looked at as 5 is greater than negative 2x minus 3 and negative 2x minus 3 is greater than or equal to negative 1. So if you want to look at it as two separate problems, that's fine. You go ahead and solve each one separate. Add 3 to both sides, and you get 8 is greater than or equal to negative 2x minus 3. The 3 goes away. Then go ahead and divide by negative 2. So negative 4, we just divided by a negative 2, so that's going to flip our inequality, is less than x. Then we can come over here and work our second problem. We can add 3 to both sides. We have negative 2x is greater than or equal to 2. We can divide both sides by negative 2 again. And x, flip the inequality, is less than or equal to negative 1. We can then put it back as our simplified form, that negative 4 is less than x, which is less than negative 1. To go ahead and graph that, we would go ahead, put our two endpoints. Remember, we're in numeric order on a number line order. We would have closed dots at both negative 4 and negative 1, and we shade between them. So if we want to do this the shorter way, we don't necessarily have to break up the original problem. We can just remember the rule that we need to be fair, that whatever we do to the equation, we have to do to everything. So when I add 3 to this expression here, I have to add 3 to all 3 sides. That gives me 8 greater than or equal to negative 2x, the 3 goes away, greater than or equal to 2. I go ahead and divide by negative 2. But if I'm going to divide by negative 2, I have to do that for all the sides. So negative 4, remember dividing by negative 2 flips the inequality, x, and negative 1. And I get the same answer. I just don't have to maybe spread out so much and do it as two separate problems.